This will come back when we talk about derivatives. Very, very important. So all it's doing is measuring change. In the simplest case, difference quotient, is pretty much slope. What is it? Well, take an easy function. X. So if I plug in x in y, which is f of x, what will I get right here? I'm plugging x in, so what will I get? I think you're not following my question. If y is equal to f of x, and if I plug in x or x, what would I get for y? 1.
Y.
The same thing, right? If I plug in x in f of x, I am going to get f of x, which is 1. So f of x. Now, the standard definition goes like this. So you are at this point, you take a few steps, some real number of steps, and you move forward, and you get to x plus h. So how many steps did we move? H steps. So I start at x, and I move h steps, and I come to x plus h. Let's try this again. If you take x plus h and plug it in f of x, what would we get? Okay, I'm glad you didn't say 2. Good. And I mentioned that in simple terms, the difference quotient is a slope, right? So we've all been through high school, middle school, whatnot, AP calculus. How do we find the slope? Rise over run. Okay, let's rise. So what would that be?
Rise.
Yes, and what will that equal to? Okay, how about this? We'll connect the dots back to high school. Y2, Y1. Now tell me, what would that part be?
Y2 minus Y1.
Y2 minus Y1, okay. But I'm going to replace Y2 by f of x plus h. Y1 is f of x. Good. In terms of f of x, that's what I have. All I did is do y2 minus y1, definition of slope. If I call this as x1 and call that as x2, what would that part be? It'll be x2 minus x1. Yes. So what is x2? X plus h. What is x1? X. What happens? These two will get cancelled. So we'll simply get h. So dq, think of Dairy Queen. Lunchtime. Okay. So dq is nothing but the slope. We know that would be rise over run. In terms of the function, what was the rise part? It was f of x plus h minus f of x. What is the run part? Simply h. That is the formula for difference quotient. Good. Again, understand the concept behind the difference quotient. Anyone can memorize a formula, but understanding is key. So, any questions on this? Okay, I'll do a very simple problem, and we can continue this with a few more problems next time. Simplest case, y equals x. Right? It's a line. Do we agree?
Yeah.
X plus b, you know the answer already. Difference quotient is pretty much a slope. So what is the answer here? It should be
One.
1. Why is that?
Because when it comes to a straight line, like y equals x is just.
1 here, right? 1 times x, b is 0. Okay, put it in the formula. The formula says f of x plus h minus f of x divided by h. Yes? Taking x plus h, plugging it in there, what would I get for y?
H. X plus h.
X plus h. Let's try again. If you took x and plug it in there, what would you get? X. The denominator is h. What happens to those x's? So numerator is h, denominator is h. The answer is 1. I knew this from the get-go. Right? So difference quotient is very much like, it is sort of a slope. But why do we have to define this? This will tie into derivatives, the concept of derivatives. One important thing to note here, if you are dealing with difference quotients, the original function, which in this case x, will always get cancelled if you have a polynomial function. As you do the calculation, suppose you have the function xy plus 1, you're doing all the work, and if that xy plus 1 doesn't get cancelled, then you made a mistake somewhere. So the original function will always get cancelled as you do the calculations. And I'll show a couple of cases next time. So if you have questions, talk to me. Definitely we will wrap this up 1.1 next time.